Hello students, we will start with the fourth chapter in Science 1, that is effect of electric current. Now in 9th standard you have studied about current electricity. Do you remember about current electricity? How does a current flow? What is potential difference? What is a circuit? There are conductors, insulators and many things which are related to the electric current. Now in this chapter we will be studying about the effects of electric current. So if you have to define electric current, so it is nothing but the flow of electrons in a conductor. Or you can also say that it is the amount of electric charge which is flowing through a particular cross-sectional area in unit time. Now for the current to flow, we require a proper electric circuit. Do you all remember what is electric circuit? It is a continuous path of an electric current through conducting wires which are connected to ends of a cell and the other resistance. So we apply two wires and we also apply resistance to it, which can be applied in parallel or series manner. Now these is when all these things are there and we have a proper continuous path, then that is called as an electric circuit. Now how the current flows. So the current flows because of the electrons which are there. Now we all know that a positive charge flows from a point of higher potential to a point of lower potential. But in electricity, due to the conduction of negatively electrons, now all the electrons are negative. So electrons always flow from a point of lower potential to a point of higher potential. So here in this figure, the electrons will flow from the point of lower to higher, that is from point B to A, and it will keep on flowing continuously until both the conductors, that is A and B, have the same potential. So the difference in the potential difference between the positive and the negative terminal of a cell is called the potential difference of the cell. Now you may think, what is a resistor? So we have already studied that when a potential difference is applied between the two ends of a conductor, so the electron starts to move from the end of lower potential to the end of higher potential. And this directional motion of the electron causes the flow of current. Now, the moving electrons, they strike the atoms and ions which lie along their path, and such collision causes hindrance to flow of the electrons and oppose the current, and this hindrance is called the resistance of the conductor, and these resistance can be provided by the resistors. So we actually try to hinder the current. We can even reduce the current from these resistors. You must have also seen in many batteries, these small resistors are applied. This is to slow down the current or to just change the amount of current that is flowing from the particular direction. Now let's understand the energy transfer in an electric circuit. Now here in this figure, I is the current and VB is the potential difference that is created between the point A and B. And the potential at A is higher than the potential at the point B. So as the potential A is connected to the positive electrode of the cell and B is connected to the negative electrode of the cell. So now here what happens is that a charge is given and a charge flows. Now from where the charge will flow? The charge will flow from point A to point B. Now you may also find that this is a resistor. So a charge is flowing from point A to point B. So what happens is, now here we have our potential difference. So a work is created because of the charge is flowing. So this work which is created, that is VBQ. So Q is nothing but the charge. So VBQ is the work that is created here while it is going from A to point B. Now you may think from where this energy comes. So the energy comes from the cell. We are applying the charge from the cell. So in the first case, that is, a charge is flown, the charge is Q, and from the cell a charge is flown and the charge flows from A to B. So what do we get? The work which is done will be, that is VB, this is the work done along with Q, जो charge flow हुआ है उसके साथ में. So that will be what? VBQ. Now in the next scenario, Again, the charge is flown, a charge is Q, but now it is flown in a particular time, that is in a unit time. The charge which is there, that is Q, it flows from A to B in time T now. So that means what is happening? The work is performed in a particular time only. So at this time, the energy which is there, that is VBQ is our energy, is given to the resistor here. And then this energy that is given to the resistor, it gets transformed into heat energy, and the temperature of the resistor is increased. That is why you will think, you may also have seen that whenever you are using more amount of more amount of any type of electrical appliance, then it starts to heat up. There is a heat which is produced. So this heat is produced because of this resistor only. वो जो charge था, that is being given to this resistor, and that resistor, it tries to absorb that extra amount of charge, and then it heats itself, and that is why that is the heat that is converted. So this electrical energy is converted into heat energy by this resistor, and that is why you can feel, even if you use your cell phones for a long period of time, you may see that your cell phones become a little hot. So that is the energy is being converted to heat energy. Now let's derive the derivation. Now this derivation is the Joule's law, and we will be deriving it by the diagram that we had seen earlier. So now we had saw that power is equal to work upon time. Now here electrical power is equal to energy, because work was done as the form of energy. So energy upon time. Now the energy that we had used there was VBQ, that is VB, which was there according to the potential difference, and Q, which was the charge, upon the time T. Now we all know that Q upon T is I, that is current is equal to charge upon time. We have learned this in 9th standard. So Q upon T is I. So P becomes what? VBI. Now, what is the heat that is produced in the resistor in time t? So for that, we need to find out the heat that is produced. So heat is equal to nothing but the power into T. Now here our P is nothing but VB into I into T. So this is our first, that is the equation. Next we have that according to the Ohm's law, we have learned last year that V, that is potential difference, is equal to I into R. So this we have learned. Now this formula we have to put here. So this becomes what? H, that is heat, is equal to V square AB into T upon R. Or it can also become H is equal to VB into I into T. So VB is equal to what? I into R. So this becomes I into R into T. So I and I is square, that is I square into R T. R is the resistance here, and T is the time, I is the current. So what we got, our final equation as H is equal to I square, that is current, into R into T. And this is called as the Joule's law of heating. So heat is equal to current square into resistance into time. So this thing, that is, this is our last final equation that we got. This is our final equation that we have got. Now next is, what is the unit of power? So unit of power, that is P is equal to VB into I. V, that is potential difference, is always volt. So volt into ampere. That is our main first thing. Second is 1 volt into 1 ampere is nothing but 1 joule upon 1 coulomb into 1 coulomb upon 1 second. So that is 1 joule upon second, which is W watt. So thus the unit of electric power is watt. Now this, that is electric power unit, we have already learned in 9th standard. You can even refer your 9th standard textbooks. So this is the main equation that we have got, that heat is equal to I square into R into T, and this is called as the Joule's law of heating. Next we will be learning about the heating effect of electric current. So now we learned that resistor is connected in an electrical circuit and heat is produced in it due to the current. So as we try to move the current. So because of that current flowing and the resistors as it is connected there, amount of heat is produced, and this heat is called as the heating effect of electric current. Now, one thing you must have observed that whenever you are using many types of equipments, they always heat after certain time. So this is called the heating effect of electric current. Now, in most of the equipments like water boiler, electric cooker or electric bulb, all of these use the heating effect of electric current only. But the conductor which is used to make the resistors, that is different. So that thing can be made up of many different types of materials. So the coil is made inside, and this coil can be made up of alloy or nichrome, and sometimes tungsten is also used. So these are the resistors which heat up, and because of which heat is produced. Now, if you will see a electric bulb, you can find there is a small wire which is connected through which the light is generated. So, in the electric bulb, tungsten wire is used. And as the current is flown, so wire gets heated and emits light. And the hot wire also radiates heat to a certain extent. So that is why what you can do is whenever you light up a bulb, after some time if you will touch that bulb, you will see that the bulb is a little hot. So that is, it is emitting heat out of it. Now, how does the electric bulb work? So here we have a screw cap. The outer covering is made up of glass. Inside we have a glass support here, and inside this glass bulb we have vacuum or even sometimes nitrogen gas or the inert gas is filled. Now here you can find there is a wire, or you can say a coil. Now this is called as the solenoid type coil, and this is made up of tungsten. So now what happens is that the bulb, it consists of glass and the tungsten, that is, this is the coil. And as the current passes through the filament, that is the tungsten coil, so heating and the temperature, as it starts to heat, the temperature is produced, and that is the reason why the light is emitted. Now, the enclosure, if you will see, there is a vacuum, and this preserves and protect the filament, that is the tungsten, from evaporating. So as it is heating, so this wire can also evaporate, and that is why sometimes it might also burst. Now solenoid type, that is the coil which is used here. So here we always use tungsten metal, and this is always done because its melting point is very high. So when a high amount of current is passed through it, it becomes red hot and it starts to emit light without getting burned. And that is the reason how the bulb, it glows, and also it do not burn very easily. But after some time, if there is more amount of current which is not able to be adjusted by the tungsten coil, at that time it might get burned, and that is why we say that the bulb has fused. Now, many times you must have heard about various accidents that occur because of electricity. That is, it can happen that there can be short circuit or a building catches fire. So these short circuits and the incidences can be avoided by using fuse. Now, actually what happens is that in our home, there are three types of wires. There are live wires, neutral wires, and earth wires. Now the live and neutral wires have the potential difference of 220 volt, and the earth wire is connected to the ground. And due to the fault in the equipment, or if even the plastic coating which is there, the live and the neutral wire, they can give away, and the two wires can come in contact with each other, and due to which a large amount of current is produced, and this produces a large amount of heat also. And if any type of flammable substance, it comes in contact with such type, then it can also catch fire. So to avoid such mishap, what we use is we use a fuse wire which is used so that these type of incidences can be avoided. So what happens is when we get the high current for any type, or it's for the any reason, if there is high current which is flown in a circuit. So these fuse wire, they melt down and they break the circuit, and as soon as the circuit will break, so there will be no type of current will be flowing and there will be no heat which will be producing, and that is why such type of mishap can be avoided by using a fuse wire. Now, fuse wire usually melts and the electricity gets cut down, especially when we use large amount of electricity. Especially in summer season, you will see that most of the time there has been the incidences of the electricity or the power getting out. So that is because sometimes these there, as we all use more amount of electricity in summer season, so that is why what happens is the fuse wire which is there, they melt down, and because of which the current is reduced, that is the circuit is which was connected, it is broken, and even any type of mishap can be avoided, but it only happens when the large amount of current is flown in the circuit.